So previously we've looked at using a stack, a last in, first out style of data structure, where we used a linked list. Now I want to show you how we can do it with an array. And I'm going to specifically show you how to do it with a fixed size array, like you might find in C#, Java, C++, or another language like that. Now I'm using Java and I've created a class called stackArray. I have two empty constructors I'll need to fill in. I also have the exact same methods I had before in my previous stack. A push to add new values, a pop, and a top. If I come over here to my stack real quick, you can see this where I have a constructor, a push, a pop, and a top as well. So nothing has changed in that aspect. I'm still using an integer as my data that I'm going to be holding. Of course, I could have any other type of value I wanted to. It's just a matter of swapping it out. I'm using integers because it's simple and easy to use. So how are we going to do this? Well, we're going to need to first have a private array that we can store information in. Unlike our stack where we use a linked list, we're also going to need to use an index. And this is going to tell us where in the array we're currently working. Finally, I may need another variable to define the size of my array. Now, if I'm using a language like Java, which I am here, I can get the length of an array very easily. But if I was using something like C++, which doesn't have a way to easily calculate the array length, then I would use a variable to store it. Since this is Java, I'm not going to use that. I'm just going to use the built-in features, and let's go from there. So the first thing I'm going to do is I'm going to work on my constructor where I'm passing in the size of my array. This.data is going to equal a new int, and I'm going to specify it as the size that I pass in. This way, if I know that I'm going to need a large array, I can pass in a large value. If this is going to be a small stack, not going to have a lot of elements, I might pass in 10. It's just depending upon what my needs are. It gives me some flexibility. This.index, I'm going to set equal to -1. Now, you might be thinking, -1, why would you do that? An array starts at index of 0. But I don't have any values inside of my array. And so I'm going to use a value of -1 to define the fact that, hey, this array is empty. Okay, so let's look at the next thing we're going to do. Inside my array where I don't pass any values, I'm going to call a constructor, and I'm going to give it that default value. So I just gave it a default value, passed it in. This is going to set my array size and the length of it to be 10 by default. It's going to go in and set my index. All that is done. So very, very simple as far as how that goes. So now I'm going to go into my push method. Now, I could rely on a try catch in order to handle what happens if I go beyond the size of my array. But I believe it's better to prevent errors like that from happening if I can. Now, how I want to do error handling is completely up to the application. But for our example, what we're going to do is we're just simply going to ignore anything that's beyond the size of the array. So the first thing I'm going to do is I'm going to specify an if statement. I'm going to say if this.index plus 1 is less than this.data length. So let's take a look at this and see how this is going to work just logically. Let's say I have a data array that has 10 elements, and my current index is 5. 5 plus 1 is less than that 10. We're going to be able to push that new item onto the stack. But let's say our index is 9. 9 plus 1 is 10. That is not less than data.length. That would cause an array overflow. And so we are not going to be able to push that new data on. In our case, we're just ignoring it. So how are we going to actually add this value? Well, now that I know that I can, I'm going to say this.index plus plus. This is going to increment my index. Then I can say this.data square bracket this.index equals the value that I'm passing in. So very simple as far as how that goes. Now, if I want to pop the value off of the stack, if I don't have anything there, I'm going to return 0. So let's see what happens and how we're going to test for that. Well, once again, I'm going to use an if statement. And I'm going to say if this.index is greater than or equal to 0. Now, the reason for doing this is very simple. I know that an index to be valid inside of an array in Java has to be between 0 and however big my array is minus 1. So if I just check to make sure it's greater than or equal to 0, I know that I have a good index that I can get a value from. And in my case, I know that's where I put some data. So I'm going to specify my local variable value is going to equal this.data, this.index. And then I'm going to say this.index minus minus because I'm removing that element from the consideration array. Now, in reality, that value is still in the array. I could go in and wipe it out if I need to, but it's not necessary. I'm using that index variable to point into the array of what element I want to get. So what I'm going to do is going to move my index down by 1, ignoring any of those previous values. If I push new values on, that data is going to be overwritten. So this is just a really efficient and effective way for doing it. We want to be very mindful of our speed, and every little bit of improvement in performance helps, as this is going to be something that's going to be used a lot. Now, for our top, it's almost identical. In fact, the only thing I don't do is I don't need to decrement my index. So once again, I can either copy and paste that in, or I'm just going to type again. If this.index is greater than or equal to 0, value is going to equal this.data, and then I'm going to index it at this.index. Once again, top does not remove that element. It just is kind of a little way to peek at it. And if we think about this, I might have the index be 5. So I say, okay, this.data 5, and it gets a value. If I have only one element, my index is 0, because remember, no value starts off at -1. And so if I have no values at all, I see at -1, and I don't return anything, or I return 0. If my index is 0, I can still return that very first element in my array. Now, if I want to, I can very easily add a counter to this because I have the index. And I can just say, hey, return my index plus 1. And that's going to give me how many elements are in here. So let's double check and make sure this is working real quick. In my Stack app, you can see my content that I have here. And I'm going to run this just real quick. And you can see my code results is 10, 0, 16, 9, and 11. And I'm going to change this, instead of being stack, to stack array. And because my push and pop method names are exactly the same, I'm going to run here again. And you'll notice that I'm 10, 0, 16, 9, and 11. The exact same results, regardless of if I used an array to do it or if I used a linked list to handle it. So just two different ways of handling the same type process. There's advantages and disadvantages between speed, memory usage, etc. But it works in the exact same concepts, and it's easy to implement in a language, even if it's a fixed array size language like you have in Java.